All right, this is Geometry B, Unit 2, Lesson 7, Polygons in the Coordinate Plane. We're going to look at a couple of examples here and try and determine exactly what kind of polygon we have. So here's one. We'll call this question number 1. Question number 1. And here are the vertices. Point A is at 4, 6. Point B is at 1, 0. Point C is at -1, 3. For these questions, I highly recommend using graph paper. You can, if you don't have graph paper, you can Google free graph paper. You can find plenty of websites that will allow you to specify exactly what kind of graph paper you want and print it. It is cheaper to buy it in tablets if you're going to use a lot of it, and so I recommend buying it before. But if you need a single sheet, you can always get a single sheet. All right, so graph it. Let's graph it. So all of these numbers except the -1 are positive, so we're mostly in the positive quadrant. So I'm just going to put a little plus sign for the origin here. A is at 4, 6, 2, 4, 2, 4, 6. A at 4, 6. B is at 1, 0. B is at 1, 0. And C is at -1, 3. -1, 3. Did I write that correctly? -1, 3. All right? Because the question is, what kind of triangle is this? What kind of triangle is this? All right? And C is -1, 3. -1, 3. Yep. All right. So let's draw the triangle. Now you might take a guess. It appears to be a scalene triangle. That is, none of the sides appear to be the same. It appears that like it might be a right triangle. It might be a right triangle. Okay? To determine if it is scalene, that is, if all the sides are different, we would need the distance formula. The distance formula. And here's how I do that here, because we're going to have a lot of calculations here. We're going to try and simplify as much as we can. Distance is about distance between. The distance between 4 and 1 is 3. The distance between 6 and 0 on the number line is 6. So the distance formula is 3 squared plus 6 squared, or 9 plus 36, or 45. Square root 45. That's AB. AC is 4 to -1 is 5. 6 to 3 is 3. 5 squared is 25. 3 squared is 9. We have 34. So these are not the same. And just to finish it off, BC from -1 to 1 is 2. From 3 to 0 is 3. 2 squared is 4. 3 squared is 9. 4 and 9 is 13. So we have confirmed this is scalene. None of the sides are the same. Okay. Now what about the claim that it might be a right triangle? For the right triangle, we're going to use slope. We use distance for whether it's scalene or isosceles or equilateral. Okay? To analyze angles, we need slope. So let's find the slope of AC, the MAC. And we have change in y from 6 to 3. From 6 to 3 is down 3. From 4 to -1 is down 5. So the slope of AC is negative divided by negative is positive, 3/5. And the slope of BC is change in y over change in x. So 3 minus 0 is 3. Change in y over change in x. And from -1 to 1 is up 2. Okay, So 3/5 and negative 3/2, right? Because it's going down. Negative 3/2. These are not negative reciprocals of each other. Okay? So they are not perpendicular as well. Okay? And so we would say this is probably an acute triangle, though there could be an argument for it being obtuse, but we don't have a way to find the angle, whether it's bigger than 90 or less than 90, but we know it's not 90. Okay, so that's one way. We can use the distance formula to measure distances. We can use the slope formula to determine if lines are parallel or perpendicular. Negative reciprocals are perpendicular, and if the slopes are the same, they're parallel. All right, let's look at one more here, and let's analyze what kind of shape this is. So we have, I'll call it question number 2. We have A, -3, 4. We have B, 2, 0. We have C, -6, -10. We have D, -11, -6. Okay, so let's graph this. So this is a lot of negatives, so we're going to be using the third quadrant quite a bit. -3, 4. So 3, 2, 4. There's A, -3, 4. 2, 0. There's B at 2, 0. C is at -6, -10. So 2, 4, 6. 2, 4, 6, 8, 10. C is at -6, -10. And D is at -11, -6. So 2, 4, 6, 8, 10, 11, 2, 4, 6. Okay, D, -11, -6. Now you could guess as to what kind of shape we have here. It's a quadrilateral for sure. Okay, there is a possibility it's a parallelogram, in which case I would need to test the slopes to determine if they are parallel. There's a possibility that it's a rectangle, which is also a parallelogram, and again I would use the slopes to determine if the angles are right angles. Okay, another test to determine if it's a parallelogram is if the opposite sides are congruent. And that would be a way to test for a parallelogram. But since both rectangle and parallelogram require me to find the slope, I'm going to find the slope. So the slope of AB, the MAB, change in y over change in x, from 4 to 0 is down 4. From -3 to 2 is up 5. So that has a slope of -4/5. Okay? The slope of CD on the other side is down, so -6 minus 10, and you can count too on your graph, down 4 over 5. So down 4 over 5, or we can do -6 to -10 is down 4. And from -11 to -6 is up 5. So these two are parallel. AB is parallel to CD. AB is parallel to CD. Okay, let's find the other slopes. The slope of AD, the MAD. Okay, the MAD, slope of AD. So 4 to -6, change in y, 4 to -6 is down 10. -3 to -11 is down 8. Negative over negative is positive, and let's reduce 10/8 by 2, and that reduces to 5/4. So the slope here is -4/5, and the slope here is 5/4. Okay, and the slope of 5/4. The slope of BC is down 10, and from 2 to -6 is down 8. Negative over negative is positive, 5/4. So I know that these two are the same slope, so AD is parallel to BC, so I verified that this is a parallelogram. But is it a rectangle? If By the way, another test for a rectangle is if the diagonals of a parallelogram are congruent. So I could do that. I can find the length of AC and DV. But I'm going to use what I have. If I look at the slopes, AB is perpendicular. AB is perpendicular to BC. Because the slope of AB, negative 4/5, negative reciprocal is the slope of BC, 5/4, negative reciprocal. Also, and I could go through all the same and all the other angles as well. They're all right angles. So 4 right angles makes it a rectangle. So rectangle is the best answer as to what this is. Yes, it's a parallelogram, but more restrictively, it's a rectangle. All right, I hope that helps.